Introducing functions, lesson 12 notes. Example number 2. The graph below shows the ages compared to heights of trees in a park. Determine if the relation given by the graph is a function. First of all, this is a scatter plot. It's a scatter plot because trees don't grow the exact same amount all the time, so it's not a linear relation. It's a scatter plot. Some trees grow faster than others, so their age and their height will vary. All right, so looking at this, we need to determine if it is a function or not a function. Well, in order to do that, we need to understand what are my input values and what are my output values. Well, remember, your input are your x values, and this is the x-axis. So your age is your input. The age is the input. We're going to go ahead and write in the missing numbers. So this would be 1, 3, 5, and 7. So your age is the input, making, this axis here is the y-axis. That means the height is the output. The height is the output. And again, I'm going to put in my missing numbers of 2, 4, 6, and 8. Okay, so what I want to do is I want to look at each input and see how many outputs there are. You do not need to draw this dotted line. I just want to show you using this dotted line. Okay, so let's start with the input of 1. The input of 1, all right, how many outputs, how many points are on that vertical line there? There's only 1. Okay, so let's go to the input of 2. How many points fall on that line? Only 1. Let's go to 3. How many points fall on that line? Only 1. So the input 3 has 1 output at 3. Input 2 has 1 output at 5. Input 1 has 1 output at 2. 4, there are no outputs, so I'm just going to skip it. 5, how many outputs does 5 have? 1, which is 9. 6 does not have any outputs, so I'm going to skip it. 7, input 7 has 1 output. So again, input 1 has 1 output of 2. Input 2 has 1 output of 5. 3 has 1 output. 5 has 1 output. 7 has 1 output. So each one of these inputs has exactly 1 output. Therefore, yes, it is a function. Now, what I did there with those vertical lines is actually something we call the vertical line test. When a relation is represented by a graph, the vertical line test can be used to determine whether the relation is a function or not. So again, when a relation is represented by a graph, this only works when it is a graph. So if you have a graph, you can use the vertical line test to determine if the relation is a function or not. Pause your video, fill in your blanks, and then also finish the definition for vertical line test, which is everything's typed except for what I am highlighting now. Okay, so your vertical line test states if a vertical line can be drawn so that it passes through more than one point on the graph, then the relation is not a function. Okay, so let's look at these examples. I'm going to drag this across the graph. If at any point it goes through more than one point on the graph, then it's not a function. So let's look. As I drag this across, it only goes through one point, only goes through one point, only went through one point, only goes through one point, only goes through one point. So this is a function, and I want you to put passes the vertical line test. if I draw a vertical line anywhere on that graph, anywhere, it would not go through more than 1 point. Let's look at the next example. Goes through 1 point, goes through 1 point. When I get here, it goes through more than 1 point. So, circle these. All right, because on that vertical line, it would go through 2 points. That makes this not a function. And then off to the side, I would like you to write does not pass the vertical line test. Does not pass the vertical line test. Okay, so again, if you have a graph, you just want to drag a vertical line across it. You could use a straight edge, you could use a piece of paper, or you could just mentally look to see if you would draw a vertical line, if it would go through more than 1 point, it would not be a function. All right, if you have any questions on the vertical line test, please let me know.